Thousands of years ago, there was no electricity, no modern machines, no computers. And yet, ancient people created incredibly complex technologies. They made materials that survived for thousands of years. And they built massive monuments that are still standing today. The real mystery is, how did they learn to make them? Did ancient civilizations know far more than we give them credit for? Or did they discover remarkable techniques that disappeared along with their civilizations? And how much knowledge once existed, only to be lost forever, never passed down to us? We often assume that modern people have always had better technology than those who came before us. But history doesn't move forward in a straight line. A civilization may spend centuries developing a single technology, yet all it takes is one generation that no longer understands it for that knowledge to disappear. And perhaps what makes ancient technology so mysterious isn't that it cannot be explained. It's that we still have the finished creations, but we've lost the people who knew how to make them. Why did humans start inventing? Thousands of years ago, people didn't create technology to amaze future generations. They created it because they had problems that needed to be solved. They needed to know when winter was coming, when to plant their crops, when the seas would change. They needed to build larger structures, create materials that would last longer, make tools that worked better, and sometimes they needed to understand the movements of the sky above them. Every problem created a question. Every question led to an experiment, and centuries of continuous trial and error could eventually produce an entirely new technology. This is something we often forget. Ancient people didn't sit down and decide to invent something far ahead of its time. They were simply trying to solve the challenges of their own world. And sometimes the result became so sophisticated that thousands of years later, we still find ourselves asking, why did they need to create it in the first place? Antikythera. Why did they need such a complex machine? Let's go back more than 2,000 years. No modern clocks, no telescopes, no satellites. And yet, the sky meant everything. The movement of the Sunday helped people keep track of time. The cycles of the moon shaped their calendars. The changing seasons determined agriculture. And events like solar eclipses and lunar eclipses carried enormous significance for ancient societies. For generations, people watched the sky. They recorded, compared, calculated. But there was a problem. The cycles of the heavens weren't simple. Some lasted for years, others for decades. No single person could easily grasp the full pattern all at once. And perhaps that is why mechanical devices, like the Antikythera mechanism, were created not to prove that ancient people were brilliant, but to transform the invisible rhythms of the heavens into movements that could be seen with the human eye. Turn a single crank, and the gears begin to move. The Sunday, the moon, the calendar, the cycles of eclipses, all modeled inside a small bronze box. They turned the sky into a machine. But here's the twist. Building such a device required far more than a gifted craftsman. It demanded generations of astronomical observations, mathematicians who translated celestial motion into numbers, and skilled artisans who transformed those numbers into precision gears. The Antikythera mechanism didn't appear because one genius suddenly imagined it. It existed because an entire civilization had accumulated enough questions and, over centuries, enough answers. Roman concrete. Why did they need a material that could last for centuries? As the Roman Empire grew, its cities grew with it. They needed bridges, roads, aqueducts, harbors, public baths, temples, and structures on a scale the world had never seen before. Natural stone was incredibly durable, but quarrying it, transporting it, cutting it, and fitting together massive stone blocks required enormous time and effort. The Romans needed another solution, a material that could be mixed, poured, shaped, and used to build on an unprecedented scale. Over generations, they experimented with lime, water, stone, crushed brick, and volcanic ash, They didn't need to understand molecular chemistry. They simply observed which mixture lasted longer, which volcanic ash performed better, which material could survive constant exposure to water. Every structure became a massive experiment. Every failure became a lesson. And over centuries, that knowledge continued to grow. Roman concrete didn't exist because the Romans wanted to create a mysterious material. It existed because a vast empire needed to build faster, bigger, and stronger than ever before. The Lycurgus cup. Why create an object that changes color? But not every ancient technology was created to solve a problem of survival. As societies became wealthier, new needs began to emerge. Distinction, power, status, religion, art, and the desire to create objects that no one else could possess. The Lycurgus cup is a perfect example. Under reflected light, the cup appears a deep green, but when light shines through it, it transforms into a glowing red. Why would an ancient craftsman devote so much effort to creating something like this? Perhaps the answer isn't found in science, but in human nature. A craftsman wanted to create something more beautiful, more rare, more astonishing than anything that had come before. So they experimented with different minerals, added metals, changed the temperature, refined the process. One attempt failed, then another, until one day, an extraordinary effect appeared. Perhaps they couldn't explain why it happened, using the language of modern science. But they knew how to reproduce it, and sometimes curiosity, combined with the desire to create something beautiful, can push technology further than anyone imagined. Metallurgy. Why did humans refuse to stop with copper? An axe, chips, a blade, bends, a tool, breaks. To us, it's simply a damaged object. But to an ancient metalworker, it became a question. Why? Why is this metal softer than the other? Why does one sword keep its edge longer than another? Why does the same ore produce different results? For thousands of years, people experimented. They changed the temperature, changed the fuel, mixed different ores, hammered, heated, cooled, then heated again. They had no modern laboratories, but they did have thousands of rounds of trial and error. Each generation kept the methods that worked, discarded the ones that failed, and passed their knowledge to the next generation. Better metal created better tools. Better tools cleared more land, cut more timber, built faster, and made possible entirely new technologies. This is how one small improvement can transform an entire civilization. Monumental stone structures. Why build something so enormous? This is perhaps the greatest mystery of all. Why did ancient people spend decades moving massive blocks of stone? Why did thousands of people work together to build a pyramid, a temple, a great wall, or an entire city? Was it simply to create a place to live? No, these monumental structures served purposes far greater than shelter, religion, power, a shared identity, control of resources, social organization, and sometimes the desire to leave behind something that would outlive the people who built it. But a great ambition creates great challenges. How do you move stones? Weighing tons? How do you lift them into place? How do you measure with precision? How do you feed thousands of workers? How do you organize people for years or even generations? Every challenge forced them to find a solution. Transport roads, ropes, levers, boats, surveying systems, labor management, food storage, and specialists who devoted their lives to mastering a single craft. And here's the twist. Perhaps these monumental structures weren't simply the result of advanced technology. Perhaps the determination to build them is what forced humanity to invent new technologies. In the first place, the greatest legacy of ancient technology, perhaps ancient technologies, are not evidence of a supernatural world, not the remnants of civilizations, with powers beyond science. Instead, they are proof of something far closer to us, and perhaps even more extraordinary: the human capacity to learn. A metal worker spent an entire lifetime understanding a single metal. An astronomer watched the night sky for thousands of nights. An engineer tested dozens of methods before discovering a better one they never imagined. That thousands of years later, we would uncover what they had created. They never knew. We would place their work inside museums, scan it with x-rays, study it under microscopes, and spend years trying to understand how they did it. They were simply solving the problems of their own time, then passing on what they had learned to the next generation until a war broke out, a city collapsed, a language disappeared, or the last person who carried that knowledge had no one left to teach, and the knowledge was lost. Perhaps the greatest mystery of ancient technology isn't how were they able to create it, but rather how much else did they once know that we will never recover? Because the history of humanity isn't only the story of what we've invented, it is also the story of the knowledge that was preserved, the knowledge that was lost, and the countless anonymous people who devoted their lives to adding one small piece to humanity's shared understanding. And perhaps the greatest gift the ancient world left behind wasn't a machine, a material, or a monument. It was a reminder. Civilization doesn't move forward because one generation knows everything. It moves forward because each generation doesn't have to begin again from zero.